Hey, here is a video for you that's got me doing this, Graphing Practice 1 linear graphs. If you have not attempted this already yourself, then you are not watching this video at the right time. So go ahead, Luger, that's not a thing. Logger, there, just finding Logger Pro. Like that. I actually have a link on my desktop. But anyway, if you have not done this, attempted this yet on your own, then you need to do that before you watch this video. All right. So assuming that you have done that, let's get busy here. So graph each data set in separate graphs. First column in each one is the independent. That means it's going to go here, which means it's going to go on the horizontal axis. Second, it's a dependent, and then answer the questions. All right, it says plot the following data on graph paper. We're going to do it here in Logger Pro. So let's see. I'm going to double click on my X column. I've got time, and my short name is T, and the units are days. That looks good. Make sure all three of these always need to be filled in. All right, and you can see that showing up there. It looks good. And then here, double click on the top of my next column. This is height. Did you know that height is not a word? Some people say length, width, and height, but height is not a word. Height is a word. It's a little confusing because length ends with a TH and width ends with a TH, but height ends with a hard T there. So watch out for that. Don't say height because it's not a word. Let's see, short name. Let's call that H, as they say some parts of the world. If I say H, so do I. And the units are meters. So meters. You could just use M for short there if you want. I'm going to type in meters. All right, that's done. Notice all three of these filled in. All right, looks good. Let's type in some data. If you notice here, you can just type these in, that's fine, but they're going up by 1.5. So I can, if I want to, double click on this and do the generate values thing where I'm going to start at 0 and at 7.5. And I'm going up by 1.5s. To do that, boom, there they are. Or just type them in. All right, let's see how our height values are doing. So 1.1, 1.9, 2.5, 3.1, 4.0, 4.8. All right, I'm going to just slip this graph. Oh, oops, where'd it go? Need that here. Let's minimize that for now. All right, so there we go. This is just scaling 0 to 10, 0 to 10, kind of like your calculator defaults to some kind of screen. So I'm going to right click here and go to graph options. Oh yeah, and remember I need a title here. So height versus time, height versus time. And we can make sure probably, well, I like to have this mouse position on so I can see where I am as I hover over the graph like we did in the last video. I'm not sure I'm going to need that here, but I'm going to leave it anyway. I want point symbols to be on. I don't want it to connect points, just in case you haven't seen that. I'm going to turn connect points on. It does this thing where it just plays connect the dots with little straight lines. We do not want that. So we're never going to want that, connect points. Hope I don't eat my words there. I think we're never going to want that. I cannot think of any occasion where I have ever used that with students, except for maybe one. All right, so then I forgot what I was doing in there. I'm going to go back into graph options. Oh no, I'm going to go to same right click. I'm going to go to auto scale. That's what I was doing. I'm going to click auto scale from 0. That should always be your first try. And that looks pretty dang good, I think. So we're going to go with that. That looks nice. If you wanted to save this graph now that you have it, actually maybe you want to get your line of best fit. So here, draw best fit line through the data. There it is. And next for part B, write a mathematical equation relating the variables in this form. So what you want to watch out for is you do not want to start doing some kind of y equals mx plus b. Let me just put here a little note here, not y equals mx plus b. I mean, you could be thinking about y equals mx plus b. That's totally fine. That's awesome because that's kind of what we're doing. But none of these things will be named y, m, x, or b. So here it says show your work calculating the slope. Well, we're not really going to do that because LoggerPro did it for us. Here's the slope. But what the slope is, you know what slope is. You know what slope is? It's rise over run. So we could pick a couple points, not points from the data table, points that are on our line. So I could just move the cursor up here and say, okay, where's this point at here? See that up there? And then I could go read the point down here. And then I could pick another one and say, where's this point at? And then I could do rise over run with those 2 points. But for us, right here, LoggerPro has done it for us. There is the slope. So show your work calculating the slope. I don't need to do that because I've already got it, but I am going to go ahead and report what it is. Since all of these numbers have 2 significant figures in them, I'm going to do 2 here. I'm not going to take off points from you if you include all 4 of those, but you definitely don't want to include more than that. Now, with the little period there, sometimes it's hard to tell, especially when we're typing. I'm going to put a 0 before that just to make sure it's clear what's going on. And this has units, meters over days. This is not just a number, it's a number that has units, meters over days or meters per day. So I'm going to include that because that's part of this number. Not just 0.48, like 0.48 what? All right, so there's my slope. And here, the equation. I am in a Word document here. If you were in Google Docs, then you can use the Google Doc equation editor. I'll show you how to do that in a second. I am in Word. If you're in Word, you can do Alt plus. Oh, why didn't that work? Let's see. Insert. Blow this up for a sec. Oh, maybe because I'm in this compatibility mode, it's not letting me do that. That's interesting. All right, so I'm going to do it without the equation editor. So my equation found is H equals MT plus B. You can see right there. So H equals, now let's see, M right here tells me is the slope. That's this number, including the units, 0.48 meters over days. And that's really like over 1 day. It says over days. I'm going to put over 1 day there. I'll talk about that in a second. And then times time, not x. So this whole thing right here, that's the slope. Including those units are part of the slope. Those are the units of the slope. And then I'm going to put a little time symbol just so it's real clear. Times t. This is like that thing that instead of x, we have t here as our horizontal variable. And then I'm going to cut a couple spaces there. plus the intercept, which is, let's see, that's the b. So looking at my graph, it says it's 0.1086. I'm going to go with 1.1. That's rounding to the same number of significant digits here. 1.1, this right here digit would round to a 1 because this one is 5 or bigger. So 1.1 meters. All right, that is my equation for my line. Now, if you're thinking to yourself, whoa, that does not look like the equation for a line. Well, it does, actually, because here's it's like y equals, here's the slope, m. And look at how nice log_pro is. It tells us what the whole slope is with the units there. So nice. Times t, that's in place of x, because that's my independent variable, plus b, the intercept, right here. There it is with units. Okay, now we get into the real important stuff here. What is the meaning of the slope? What does this mean? 0.48 meters over days per day, or I put the 1 in there because I think that helps us understand what the meaning is. We're going to read the meaning of a slope from the bottom up, starting here. For every 1 day, what are we measuring the height of? I guess we don't know. It doesn't say. The height of something, whatever this thing is. So for every 1 day that goes by, the height increases by 0.48 meters. And that is exactly what I'm going to say. I don't know why it's making that little small cursor there. So for every 1 day, you could say for every day, that'd be fine. For every 1 day that passes, the height increases by 0.48 meters. Good. What's the meaning of the slope? If you were tempted to say, what's the meaning of the slope? It's the rise over run. That is totally unsatisfactory here. Because I mean, I know that slope is rise over run. Everybody who's ever taken Algebra 1 heard their Algebra 1 teacher say that a bazillion times. We all know that. It's not helpful here. So what's the meaning of the slope? You got to say what the meaning is in the context of what you're looking at, of what your data is, what your graph is representing. So for every 1 day that passes, the height increases by 0.48 meters. So I'm reading this. I'm saying for every one of these on the bottom, this happens. All right. What is the meaning of the y-intercept? Well, if you look at the graph, the y-intercept is how much of this you have when there's 0 of this. So in this case, that would be how much height you have when the time is 0. Or in other words, it's the starting height. At time 0, like 0 days have gone by, then the height is 1.1. So I'm going to say that at time 0 days, the height is 1.1 meters. And notice I'm not just saying it's the starting height. I'm referring to the specific units in this problem here. So at time 0 days, the height is 1.1 meters. You could also say, this would be fine, the starting height is 1.1 meters. That's also fine. It'll say the same thing. And then predict what the height would be at time 10 days. Now here we've got an equation, so I want to actually use the equation instead of just looking at the graph like we did in the last assignment. So using the equation that we have, I've got the height. Why is it not letting me space there? There's all sorts of weird formatting in this document, sorry. we go. So we've got height equals right, folks, stay tuned. All right, height, put a capital H there, we'll go with that, equals, let's see, my slope is 0.48 meters per days. I'm just abbreviating the meters and the days, M and D, but I'm including that, right? Times, I want to know what it is at time 10 days. So in the equation here where it says T, I'm going to plug in the 10 days times 10 days, and then plus 1.1 meters. That is a little math equation, and I'm going to do that now. So if you look at this, I got to do the multiplication first, right? Because I took Algebra 1. And notice two things happen here. I'm going to multiply those numbers together. But the D here and the D on the bottom of this cancel each other out. And I get 4.8. That's what happens when you multiply by 10. 4.8 meters. Units act just like variables. They cancel out just like variables do. And 1.1 meters. So I multiplied this together. The units, the days canceled out, and I got 4.8 meters plus 1.1. And that is equal to, what's that, 5.9 looks like? 5.9 meters. Cool. And you could check against the table here. Does that look about right? That if it was, if we plugged in 10, then it'd be about 5.9. Sure, you could check on the graph. Sure, that looks good. All right. And I think that's the end of that one. All right. Let me make a new graph here for the second one. Nope. Consider the following experimental data. What's the independent variable? It is time. And what is the dependent variable? It is distance. That's data. All right, let's do it. So let's see, I'm going to change this to time, short name, T, units, seconds. They do SEC. Seconds is usually abbreviated just S. I'm just going to do it the same as what they have here for consistency. Does that go up steady? Oh, it goes up steady. I can do my generate values. You don't have to, but you can if you know how to do this. Easy trick. I want to go up to 7.5, and I want to go up by 1.5s. All right, so there's my first column done. And my dependent variable, it's not called y, it's called distance. That's what it is. And that's going to be short, the D for that. And the units, they wrote out all of meters. Usually meters are abbreviated just M. I can't do generate values because it's not a nice little pattern. So I'm going to type those in. What I got 0, and then I got 0.45, and then I got 1.8, and then I got 4, and 7.2, and 11.1. Right. Anything missing from this graph? Got a nice label here, label here. I'm going to go ahead and auto scale from 0. That's always what we try first. That looks good for this graph. And doesn't have a title. That's a problem. So I'm going to add one. This would be, they've got it right here, distance versus time, or distance traveled versus time. So distance versus time. Got my point symbols on, especially in this one. You want to see what this looks like with the connected points? Oh, yuck. Don't like that. So if you end up with that, sometimes when you first put Logger Pro on your machine, it'll do that. So we want point symbols, yes, connect points, no. And we'll leave that on, helps us explore the graph. Okay. plot the data. Now, before we do anything else, notice that it's not asking us to write the equation for the line. Why not? Well, this is not a straight line. It is appropriate to fit a straight line to some data if it looks like it's a straight line. This is very clearly bending upward. That is not a straight line. Now, in Algebra 2, you learned about some other kinds of fits. So maybe it's something else. Maybe it's like quadratic or some other thing. We'll talk about that more in the future. But right now, all we are observing is this is not linear, so don't be doing this. You can click on this. There's your line of best fit. The computer is just going to do whatever you tell it to do. So if you look at that, that looks like total garbage. There's these 2 points way above it, and then all the ones in the middle are below. No good. Get rid of that. Okay, so predict what the distance traveled would be at 5 seconds. So here's 5 seconds right here. And it looks like it's hard. It's a little harder to do this because we're trying to guess and we don't have a straight line there. And it's good that we don't have a straight line there. That would be distracting. So maybe somewhere around here. Say the distance would probably at time 5. Looks like the distance would also be right around 5. So I'm going to go ahead and say that. It's just predict, so we're not looking for an exact answer here. We don't have an equation to use. So I'm going to say, stop doing that, please. There we go. That the distance would be about 5 meters. All right, and then give a possible scenario that could be described by this data. Well, at 0 seconds, this thing was at distance 0, and then at 1.5 seconds, it had gone like about half a meter, and then at 3 seconds, it had gone 1.8. So that's a bigger jump of distance in the same amount of time. So I guess that this must be something that's speeding up. So as this curves upward, it's covering more distance in the same amount of time. Like in this 1.5 seconds here, it covered this much distance. And then in this 1.5 seconds here, it covered this much distance. If you're thinking about the like the steepness of this is kind of like how fast it's going, that is true. So I'm just going to say here that it's an object, I don't know, it could be a bike, somebody on a bike, it could be something like rolling down a hill, an object that is speeding up. And whatever you said there, I just wanted you to think about that. All right, that is that for graphing practice number 1. Hope that was helpful for you. We'll see you sometime soon. And let's see, I'll shut this video off. All right, bye.